everyone. So today we're going to be looking at a review of solving system of equations from Algebra 1. So as a kind of reminder or warm-up, a linear system of equations is a set of equations with a common solution. So that is a system of equations, a set of equations with a common solution. A linear system of equations is going to be two equations, okay? It's going to have two equations with one or two variables. So two equations with one or two variables. And so you are going to have to recognize when you have a system. So if I see two equations that have two variables in them, I know it's a system of equations. And in Algebra 1, you learned that there were three methods to solve a system of linear equations. They were by graphing them, although that's the least accurate, okay? By substitution, and by something called elimination. Now, your teacher may have called elimination linear combination or the addition and subtraction method, but we're going to go over each one. But what you need to really realize is that the point of intersection is the solution to the system. So if I'm solving it by graphing, then the point where the two lines, since it's two linear equations, two lines, where they intersect is the solution. Now, when we do that algebraically, that means that our solution is going to be a coordinate point, okay? Now, I want you to keep in mind that the term intersect, okay? Because I said where the point of intersection. Intersect in algebra means where the equations are equal to each other, okay? It's where the equations are equal to each other. So we may use that a little bit later. All right, so let's look at an example of how we would see if a coordinate point is a solution to a system. So I have a system here, 3x minus 2y equals 2, and x plus 2y equals 6. I know it's a linear system because they're both linear equations. And as a reminder, they're linear equations because the highest exponent is a 1. All right, so if I want to test to see if this is a solution to the system, that means it has to make both of the equations true. All right, now if that is the solution, then the other one would not be because two lines can only intersect in one place. All right, so I'm going to test it. I'm going to plug in 2 in for x and y. So 3 times 2, 3 times 2 minus 2 times 2, does that equal 2? Okay. All right, so I get 6 minus 4, it does equal 2. Awesome. So now I got to test the other one. So I've got 2 plus 2 times 2y, does that, let me fix that. And plug it in 4y. So 2 times 2 plus 2, does that equal 6? So 2 plus 4 does indeed equal 6. So 2 is a solution that makes both equations true. So it is the solution to the system. So I don't even need to worry about 0, -1 because it's not going to be the solution that would make both of these equations true. All right, well now let's look at each method for solving. The first one, like I said, is the graphing method. Now, when we graph, we can graph two ways. We've been practicing these two ways. But I'm going to let you do whichever one you feel the most comfortable with, okay? So one way is to put every equation into the form y equals mx plus b, so slope-intercept form, and then use the slope and the y-intercept to graph it. Or you can use the intercept method. So use the intercepts. That means let x and y both let x and y be 0 and solve for the missing variable. So you can graph either way. For me, what I'm going to do in this first one is I'm going to actually, I'm going to graph it by putting it into y equals mx plus b because I think that's probably what most of you have already chosen you were going to do. So I'm going to subtract the 2x to the other side and I'll get y equals -2x plus 6. All right, then I'm going to graph that. So I'm going to go up to 6. Which is right about here. It's a little off the graph, and I'm going to go down 2 and over 1, down 2 again and over 1, down 2 again and over 1, and I'm going to draw a line through it. Now, I do want you guys to, when you graph your lines, I want you using rulers, especially when we're solving a system, because the more accurate you are, the better chance you have of getting the right point of intersection. Okay, so that looks about good there. There's my line. I would put arrows at the end. All right, now I'm going to do the other line. So I'm going to subtract 6x to the other side, and I'm going to get negative 2y equals negative 6x plus 10. I'm going to divide everything by negative 2. And so I get y equals 3x minus 5. Okay, so now I'm going to go down to negative 5, the y-intercept of negative 5. I'm going to go up 3, 1, 2, 3, and over 1. It's a positive slope, so I know it's rising. Up 1, 2, 3, over 1, and then up again 1, 2, 3, over 1. And when you're trying to see points of intersection, you really should go until you've at least crossed the other line. All right, I'm going to draw a line here. Let's see if I can make that as accurate as possible. Like that. And I'm going to estimate the point of intersection. Now, again, I said this was the least accurate method because look, we're going to really estimate and we're going by our eye. So I'm thinking this is about, I don't know, the x about 2.4, 2.3 for x, and about maybe 1.5 for y. All right, well, we're going to test that. So I had told you I wanted you to have Desmos open when you were doing tonight's video. So let's go to Desmos. Now remember, when you go into Desmos, it says start graphing, and this is what would appear. So I'm going to just type them in the way they're written, okay? So those equations we had, I think 2x plus y equals 6. And there's my first graph. And the second one was 6x minus 2y equals 10. All right, so now let's look at the point of intersection. So look, it's about 2.2, 1.6. So, you know, right about where we said we would be making an estimate because, you know, it's so close. So now looking back, yeah, it is about 2.2, 2.3. So that's the solution to the system. That means that's going to be the number that makes both equations true, the point of intersection of the two graphs. All right. So let's talk about graphing. When we have a system of equations, there can be several different things that can happen if I'm graphing lines. Thinking back to algebra, we know that two lines can intersect in exactly one point, and so a system can have exactly one solution, like we just did, okay? They intersect in exactly one place. All right. It also can have infinitely many solutions, okay? Infinitely many solutions means that the lines are right on top of each other, okay? So they work out to be the same line. We would say that these lines coincide, okay? And we're going to talk about these because actually one of these is an independent system and one of them is a dependent system, and we're going to talk about that in class. The last thing that can happen is that the lines don't intersect, and that would be no solution because the solution to a system is the point of intersection. But that doesn't mean that the equations don't exist. If there's no solution to the system, that means the lines never intersect, which means that the lines are parallel. Remember from geometry, two lines that never intersect, as long as they're coplanar, are parallel lines. Okay, and if we're talking about the coordinate plane, they would be coplanar. All right, now I'd like you to try the next one, negative 2x plus y equals 5, x plus y equals 2. I'd like you to solve it by graphing, and then I'd like you to check it on Desmos. If anything doesn't work or you make a mistake, go back and look at it, and if not, bring it to class tomorrow and ask about it, okay? All right, let's look at the next method, the substitution method. All right, so the substitution method, probably you're going to remember this one pretty clearly, but the substitution method really is only best to use when something's true, okay? And that would be when one or more variables, has a coefficient of 1. This is really the only time I want to use substitution. All right, well, what's a coefficient and what's 1 mean? All right, well, let's just think about it. If I give you the expression 2x, the number in front of the variable, that's called the coefficient, okay? And that would be 2. So if I'm looking for a coefficient of 1, I'm looking for either just an x or a y. Or if multiple variables are used, it could be a or b or d or f, but I'm looking for a coefficient of 1. So now that I look at this system, I've got 3x plus 4y equals negative 4, x plus 2y equals 2. I've identified it as a system of equations. I've also identified it's a linear system because there's 2 equations with 2 variables, and they're both lines. So I'm going to solve for x, the one that has the coefficient of 1. So solve for x means I'm going to subtract 2 to the other side. So I get x equals 2 minus 2y. I'm going to take that 2 minus 2y, I'm going to substitute it in for x in the other equation. So I get 3 times 2 minus 2y. Now stop if you're trying to do this on your own. You are watching and learning because you may learn something as we're doing this, okay? So we plug 2 minus 2y, we substitute it in for x. And then we add 4y and subtract 4. You have to treat these videos like a lesson, guys, not like I know how to do this, so I'm going to do it. All right, so I distribute my 3, and I'm going to get 6 minus 6y plus 4y equals negative 4. I'm going to combine the like terms, and I get 6 minus 2y equals negative 4. Subtract negative 6, so negative 2y equals negative 10, and y equals 5. Okay, but remember, we're looking for a point of intersection of the 2 lines. I only have a y. I'm going to need an xy. I need a coordinate point. So I take the 5. I do substitution again into this expression. So x equals 2 minus 2 times 5. So it equals 2 minus 10, which equals negative 8. So my solution would be negative 8, comma 5. Okay? All right, and could I check on Desmos? You absolutely can check on Desmos. You just plug in both equations and see if that works. So let's try it. I'm going to check myself. I'm going to put in 3x plus 4y equals negative 4. There's my first line in green, and x plus 2y equals 2. Okay, I look up there. Is this point right here, negative 8, 5? And look at it. Beautiful, it is. So that's the point of intersection, and I know that I've done my work correctly. All right, one more method to go. I know it's a pretty long video tonight, but I just wanted to make sure you guys felt comfortable with these 3 methods so that we'd be able to use them as we move forward. All right, the elimination method. It's also called linear combination. Or again, I told you addition or subtraction. All right, so if you need to take a pause here, take a pause, press pause, stand up and stretch, and then let's get back to work. All right, so 2x minus 4y equals 13 and 4x minus 5y equals 8. I tend to use the elimination method, so I use it when it's in standard form, when both of the lines are in standard form. And they are in the form ax plus by equals c. And I'm just really comfortable with using elimination when they're in that form. I also notice that there's no coefficient of 1. All right, now the elimination method means that you have to eliminate a variable. You can only do that if the variables are opposites. For example, I see I have a 4x here and a 2x here. It's very easy for me to change this entire equation and make that 2x a negative 4x by multiplying the whole equation by a negative 2. All right, and so I'm going to rewrite that. I'm going to multiply the entire equation by negative 2, and I'm going to get negative 4x plus 8y equals negative 26. So I just made the equation bigger by multiplying by negative 2. Now I'm going to bring this one over and rewrite it right under it. So 4x minus 5y equals 8. Now that I have one variable that has opposites, the negative 4x and the positive 4x, I can add the equations together, eliminating that variable because opposites go to 0. Negative 4x plus 4x cancels them out. Then I do 8 plus negative 5y gives me 3y. And then negative 26 plus 8 is going to give me negative 18. I divide by 3, and I get y equals -6. Okay, again, we have to find a point of intersection, so we need the other point. So I'm going to plug that in for y into either one of the equations. So 2x minus 4 times -6 equals 13. So 2x plus 24 equals 13. I'm going to subtract 24 from both sides. So 2x equals 11, or -11. Divide by 2. And so x equals -5.5. So my solution, my point of intersection, is -5.5, comma, -6. And again, I'd like you to check and make sure we did that right on Desmos. You never know. Coach Fred could have made a mistake. All right, couple things. How can this get harder? The only way this elimination can get harder is when you actually have to multiply both equations. Now, when you do that, I tend to pick the one that's going to give me the smaller values. So for example, in this next example, I decided I was going to multiply the top one by 5 and the bottom one by 7. I'm going to change the x's to make them the same. I didn't do the y's because the numbers were bigger, but it's really up to you. All right, so if I multiply the top equation by 5, I get 35x minus 60y equals -110. All right, and then in the bottom, I'm going to get -35x. There's that opposite I wanted, plus 56y equals 84. All right, now I'm ready. They're ready. I add the equations together. The x's eliminate, and I get -4y equals, what is that, -26. And I'm going to divide by -4. And I get y equals 6.5. All right, now I got to find my x. I decided to use the first equation. So 7x minus 12 times 6.5 equals -22. 7x, grabbed my calculator, 12 times 6.5, 12 times 6.5 gave me -78 equals -22. I add 78 to both sides, and I get 7x equals 56, so x equals 8. So again, there's my point of intersection, 8, 6.5, and there's the solution to the system. Now, a couple things. No matter what method you use, you're still going to have those 3 solutions. One solution, you're going to get an answer like we did in this last one, 8, 6.5. That is the point of intersection, still having one solution. Infinitely many solutions, what might happen is both variables might cancel out and you're left with a statement like this. If you're left with a true statement, this is true, 3 does equal 3, then the answer, it's the reflexive property, so it's all real numbers, which means infinite solutions, so it's the same line. No solution, your variables are going to cancel out, but you're going to be left with a statement that isn't true, something like 3 equals 7. That is not a true statement. You would say no solution, which means that the lines are parallel. All right. Quick review. A system of linear equations. I want you to write down what that is. I want you to tell me what the solution is, and I want you to tell me when when we should use substitution. So these are the 3 things. I want you to go back, read through your notes, get the answers to these questions, and bring them to class tomorrow for us to discuss. And we're going to practice all these methods tomorrow, so come ready to work. Bye, guys.